Hey guys, welcome to this session by Great Learning. My name is Anirudh Rao and I welcome you all to this session where we'll be discussing about a lot of things to know about statistics in the concept for data science, guys. Now guys, before we actually go on to begin this session, if you can see me fine, if you can hear my voice fine, if you can see the screen fine, take a quick second to head to the chat box and just type in a quick yes or a no so we can go on to proceed with the section, right? While you guys do that, I want to tell you guys that I'll be using my mobile phone to monitor all of the questions that you guys are going to ask. As always, let's keep it highly interactive. Let's keep it, on a high energy note. It's a beautiful, bright afternoon here in Bengaluru. So I welcome you all, from wherever it is that you guys are tuning in. Alright, I do have a couple of yeses in the comment section. With this, I believe that all of you can see the screen fine and hear me fine. Perfect, guys. Thank you so much. Probit, Akshat, Siddharth, Dhriti, thank you so much, guys, for the confirmation. Now, before we actually go on to begin today's session, guys, I hope all of you are keeping safe from the ongoing pandemic, taking all the required measures to stay safe, right? Now, before we head into the agenda of the session, I want to tell you something very, very important. Now guys, I want to talk to you about Great Learning Academy for a second. Now Great Learning Academy is a venture here at Great Learning where we give you guys a lot of courses for free, where you guys can first of all sign up for free, enroll into courses for free, learn for free, and at the end of it, guess what, you can get a certificate of completion absolutely free of cost as well. So whatever you find here on Great Learning Academy, right, so it's an amazing place for you guys to check out. We have 700,000 plus learners joining in from 140 different countries across the globe. We have 1,000 plus hours of free learning content catered to make sure you guys can learn effectively. We get 3 million monthly views on the channel, guys. Of course, you can take a look at all the upcoming live session from all of the subject matter experts. I am a subject matter expert in data science. You guys are tuned into my session here. These courses, guys, are put together in such a way that we can make sure that you guys are completely aware about the structured process we take into building these courses. So these will make sure you can get rapidly started in a structured way about the domain that you guys are looking for. And of course, guys, for everyone who's asking, saying, hey, is this course available in Hindi? We do have many courses available in Hindi as well. Check this out: Python programming in Hindi, Python for machine learning in Hindi. We have multiple courses. Majority of it is in English, but of course, at the end of the day, we have multiple sessions coming in, multiple courses coming in for you guys in multiple languages. Now let me quickly click on data science on the left here, right? We have 200 plus courses that you can check out, guys. In total, for example, in data science, you can opt in for the data science foundations course. For example, we have 3 levels of teaching here, guys. We have the fundamental course, which is the beginner course. Then we have the intermediate courses, and we also have advanced courses. So depending on where you are, what you want to pick up. For example, look at this. Clustering in R is a beginner course. Statistical methodologies for decision making. This is an intermediate course, and we also have an advanced program, marketing analytics, right? So we have multiple things that will interest all of you all, no matter where you are in your career. That is the advantage, right? We here at Great Learning have made sure that either you're in school, you're in college, you're about to graduate, again coming from a technical background, non-technical background, whatever it is, right? So we make sure we have a course here. No matter where you are in your career, you can definitely make use of this learning. Hey, at the end of the day, all of this that you see, all these courses are free, right? When you enroll, you get a lot about the details about the courses, the skills covered, the syllabus, and of course, this is the certificate of completion that I was talking about. This is completely free. It's going to add immense amount of value to your knowledge base, and of course, at the end of the day, it's going to add a lot of value to your resume as well, guys. You can reach Great Learning Academy in multiple places. If you're looking for a job preparation section, we have an amazing job prep session that you guys can check out. Of course, we have learning collaborators like Stanford, Texas MECOMs, Northwestern, IIT Madras, SRM, PES, among the best universities on the globe. Ladies and gentlemen, you can reach the website in multiple ways. Of course, greatlearning.in/academy is one way that you guys can join us, and you guys can take a look at Great Learning Academy app as well. Of course, we have the Great Learning app through which you can access the academy. It is available both on the Apple App Store and of course on the Google Play Store as well. So no matter what device that you guys want to join us, we bring you the best of Great Learning Academy to your fingertips, guys. So make sure you guys are checking out Great Learning Academy. It's an amazing place to be, and of course you get to learn a lot. Right, guys, now coming to our session here, right? Statistics for data science. Now, statistics is a very, very, very important concept for data science. I highly stress that all of you all who are professionals who are looking to become experts in data science give some time to learn statistics, right? But then before we dive into the depths of it, we need to understand so many different things, guys. First of all, we need to take a look at what statistics is, how it talks to data science, what is the data science life cycle itself in a way where statistics has meaning to it. We're going to take a look at the types of statistical analysis, right? It's not only like statistics is one concept that's going to apply to all. True, but this statistics itself has a lot of subdivisions as well, so that is going to add a lot of value. So we're going to check out all of that. We're going to take a look at the statistical concepts which govern the world of data science, and of course, guys, at the end of it, I am sure all of you guys are excited to take a look at Python code and understand all of this practically as well, right? So we're going to take a look at an amazing data set. We're going to perform some statistical functions on it, and we will align everything to the world of data science and wrap it up really nice, guys. But then before we actually go on to begin, make sure to subscribe to the Great Learning YouTube channel. Hit that bell icon, because as soon as you hit the bell, whenever we put out a video, right, you guys will get a notification, guys. So make sure you subscribe, and of course like and share this video with your friends and family members, or whoever you think wants to learn about statistics for data science, right, guys? Now, to start out with this session, first of all, let me give you a quick introduction to what data science is in itself, right? See, data science is one of these vast fields which again consists of so many different things on the inside. But as a whole, if you have to define what data science is, it is a study. It is a domain where we take in raw data and we apply some methodologies on it, use multiple tools, techniques, whatever it is, and we give out a result where the raw data that we took, you remember, gets converted into useful information, meaningful information, right? Now you might have a question saying, okay, so every data, isn't it at the end of the day information, right? True, there is information in the data, but on the whole, when you take a look at data, right, it is a raw entity. It remains unclean. It consists of things that you can use, things that you cannot, things that you wouldn't be of use to you, basically. If you keep all of that as well, down the line, it's going to hurt your machine learning model when it's learning. We're going to get into all the nitty-gritty details, but for now, we have to realize that this is a study. We're going to be making use of a lot of tools, algorithms, and multiple different concepts to find whatever is hidden in the data. Data science, right? We're doing something sciencey with the data. We're trying to find out what's hidden in the data, all the patterns, whatever it is that data cannot tell us when we look at it with our naked eye, and we can find a wealth of information. To do that is what we use, guys, data science, right? So you can manipulate data, you can analyze data, visualize it, you can do a lot of things with data science, ladies and gentlemen. So to talk about the rise of data science, right? Data science is one of the most popular domains out there we have in the world of information technology and all of computer science today. Why? First of all, there are large amounts of data being generated everywhere across the globe, right? We generate 26 lakh terabytes of data every single day, 26 lakhs every day. By the time the sun goes up and the sun goes down, the entire world, if you just bring it together into a hypothetical hard disk, the data is 26 lakh terabytes. Now your laptop, my laptop, the computers that we have might have 1, 2, 3, 8 terabytes of data, which we're going to take a long time to fill. But think about storing 26 lakh a day, right? That's the reason why we need data science. The second thing is, it will help all the businesses out there to make informed decisions, have data proof to whatever it is, whether they're trying to correct the past, know where to go in the present or predict the future, data science helps. It brings down production cost immensely by again, at the end of the day, understanding trends, giving you hidden patterns, things that you did not know about your own company or product. You can find a lot of that information with the help of data science, guys. So let me quickly take questions up. Let's see if any of you guys have put down any questions. Tuffy says, greetings from the Philippines. Well, Tuffy, welcome to this session. I hope you get to learn a lot. If you haven't subscribed to the Great Learning channel, make sure you subscribe. And right, guys, so Mayuk Chatterjee has a question. So before starting the session, I had a question. Do we require calculus for data science? Well, Mayuk, that's an amazing question. Yes. Calculus, there's a good chance you will not use it directly, but you use products of calculus. So if you're curious enough to find out why you do the things the way you do, for example, in the case of neural networks and a lot of concepts of machine learning, right? Things are there which will work, but for you to find out how they work, they use a lot of linear algebra and concepts of calculus. So it is definitely important, Mayuk. I hope I answered your question. Right, guys. Next, when we talk about the actual part of statistics for data science, right? See, it should come as no surprise to you that whenever you're doing machine learning, statistics is a concept which is the mathematical foundation and the most important thing upon which machine learning is built, right? So you have certain data to make your machine understand the data. You write a program, but the eventual process of your machine actually understanding the data, that comes from a lot of mathematical concepts. When you analyze something, there's a lot of mathematics involved as well. So it's very important that you know statistics, guys. So it's not only until you analyze, it's even after you analyze, right? Once you finish analysis, let's say you have a beautiful looking graph that is giving you the solution or the answer that you're looking for. Even looking at that graph, applying certain statistical methodologies on it, you can find out even more on the already existing solution. How cool is that, right? You already have a solution. You've solved the problem. Now there are better ways to do it, of course, but with the solution that you have, you can improvise it right then and there, right? That's amazing. And another reason why statistics is extremely popular, especially in data science, right? See, now if I just tell you a random thing, I can say that, hey, it's raining here, but I do not have any proof that it is raining. Well, it doesn't make sense. It is just me saying something, right? But if I said, hey, it is raining here, and I maybe give you a little bit of evidence, or I give you a proof that it is raining, right? Well, it'll make sense. Yes, it is raining. Why would I fake it? Makes sense, right? So that's the thing with data as well. Instead of just coming to conclusion or guessing it, with the help of statistics, you guys can reach a concrete solution and say, hey, this solution is backed strongly by the data that I have. I have enough proof that the result of the analytics will hold true at the end of the day, right? That's such an amazing thing to know about. And even with how you play around with data, find an immense amount of hidden insights, adding value back into your own organization or a client, well, statistics is used for everything, ladies and gentlemen. So that's an important thing you guys should know about. But then to understand about statistics, to understand about where it fits into the data science life cycle, the data science ecosystem, right? Here is a structured process that you see on your screen right now, which goes from left to right about how the data science architecture works. Now, the first thing, whenever you are trying to solve any sort of problems with data science, ladies and gentlemen, what do you think is the first thing? You have to know what is the problem that you're trying to solve, right? Understanding the business problem, knowing that you can use a concept of data science, knowing that there is something in this domain that you can use to solve the problem. Formulating an actual plan of action is something, right? It's called as a requirements document. To have all of that ready will be your first step about how you will solve a problem with data science. Once you've done all of this, the second thing is you will realize, okay, so here's my problem, this is my solution. To get to my solution from the problem, I'm going to require certain data for me to work on it, right? So if you're trying to say, hey, what is the amount of chocolates I might sell next month? Right? I might sell next month. I'm trying to predict the future here. To predict the future, I can just guess saying, hey, I'll sell 10. but eventually I could have sold 500 there. But to back it with certain proof and to give a good amount of accuracy, I say, okay, so let's analyze last month, 6 months, 1 year worth of data to see what we might find out about next month, right? So in that case, you have to acquire the data. Now, data acquiring can be from your own server, it can be from a cloud storage, it can be a little bit of public data from your competitors, it can be data from social media. Guys, data, you can find it everywhere. It can come from a million different sources, and as a data scientist or a person looking into data science, you must have the capability to bring in the data, acquire it and store it and keep it ready for pre-processing. Now, pre-processing is also involved in the second step itself, where what you try to do is you clean the data, right? At the start of the session, I told you that data is a raw entity. It consists of useful things and noise. We do not want the noise, we only want useful things, right? So once you clean all of this, data of course is like very unruly. Sometimes you have to add values, sometimes you have to delete values. There's so many different examples that I can give you. For example, if I ask what is your blood group, there can be a phone number given there. Well, doesn't make sense. I want your blood group, I do not want your phone number or your name or whatever it is, right? So in that case, you have to correct all of these things or remove them entirely. Because if you do not, look at the third step. The third step talks about EDA or exploratory data analysis, where you actually look into the data, apply these statistical methodologies that I'm about to teach you. And, there, if you do not clean the data, your data is going to be all wrong. It's going to give you incorrect result. And even then, if you cannot catch that your data is incorrect, and if you feed it to the next step, which is machine learning, right, it's going to be disastrous. Your machine does not understand a lot of things. It can be the fastest processing machine right now, your phone, your whatever it is, your iPad, your computer, your TV. These systems that we have today are millions and millions and millions of times faster than the entire spacecraft that took humans to the moon, right? So what happens is, at the most fundamental level, your computer only understands zeros and ones, and us talking to a computer in zeros and ones is highly inconvenient. Hence the reason we have high level user interfaces. We have Windows, we have iOS, all these operating systems. In that also we have a convenience. We use whenever we are writing Python code, we need an integrated development environment for it. We need a user interface and all of that, right? So coming back to the point, what happens is that in machine learning, if you teach it wrong data, it will happily learn. It has no way to verify unless you sit and verify what's going on, right? So if you are trying to send pictures of cats and dogs to your machine learning algorithm and say, hey, okay, so which is a cat and which is a dog, if you train it incorrect, it's going to look at a cat and happily say this is a dog. If you send a picture of a dog, it's going to say, hey, what a cute cat, right? So we don't want things like that to happen. That's the reason why your data has to be really clean. That is step number 4, guys. When we're talking about step number 5, right? Step number 5 talks about prediction and deployment. Model prediction is a concept where we actually try to see what's going on with the model. Has our machine learning output learned anything? Has all of our mathematical calculations, statistics powered machine learning algorithms done everything correct? So you're going to predict everything, see if everything is fine, and if it is fine, you send it for deployment, as in you actually use it to solve a problem. That is deployment, right? So this is a structured process. This is a life cycle. What happens after deployment is sometimes there arises another business problem which you have to solve with data science. So what do? So you go back, you circle back to step 1 and you do all the things that I just mentioned, right? So this is the data science life cycle, ladies and gentlemen, right? Let me take a look at your questions now. Vinay Kumar Yadav says, sir, algorithms and data structures are necessary for data science. Of course, Vinay Kumar, algorithms and data structures are the heart of data science, right? So data science, data is the first name. So you would definitely require algorithms and data structures. Ashutosh has a question. Any certification program available for people with me over 16 years of experience but without any knowledge of programming? Well, Ashutosh, I highly suggest you take a look at Great Learning Academy. We have multiple, in fact, all of the courses we have at Great Learning Academy are free. So just take a look at the foundations courses. We have intermediate programs and advanced courses that you can take a look at, enroll, complete, and get a certificate of completion for free as well. So make sure you check them out at Great Learning Academy, Ashutosh. Akshat says, are you going to teach complete statistics, whatever we require for machine learning today? Akshat, very good question. With this session, as I already mentioned in the agenda, you will, get a lot of knowledge about how we talk about different metrics, how we use this metrics. I have very, very nice ways, very nice stories to tell you guys and make sure you understand the concept. I'm going to talk about present life situations tied up to statistical concepts so you guys can learn and remember things better. Now, is this session going to cover everything there is to know for machine learning? The answer is absolutely no, because see, in 1 hour there is only so much that we can cover, right? But if you do not get the foundational concepts that I am going to talk about right now, if you do not understand all of this, then looking at machine learning or then looking into intermediate level or advanced level statistics becomes extremely difficult. So with this is what we are going to do, guys. Don't worry, at the end of the session you will be packed with information about statistics. Right, guys. Now talking about a concept where we'll take a look at data science programming, right? See, statistics is when you go on to check how things work. But to make sure that you're using these things to work with your computer, you require certain programming languages, right? So taking a look at the structured process, using the life cycle, to use the life cycle, in fact, you're going to require programming languages. For the case of data science, since you're working with data, you're going to require knowledge of SQL, Informatica, and all of that to actually go on to solve problems. A very, very, very popular programming language, of course, is Python. It's the #1 programming language in today's world. You can use Java. R language is extremely popular for data analysis. Similarly, we have SAS and MATLAB and all of these as well, guys. So, these it's not a compulsion that you require all of these, but these are some of the choices that you can use, you can pick. But my recommendation to you guys, if you're looking at statistics or data science, if you guys are starting out with data science, right, take a look at Python, or you can take a look at R programming language. Right. Now, guys, with all of these things that we just checked out, now it is very, very important that we take a look at the important types of statistical analysis that we can perform, right? In fact, there are, two different types of statistics, the analysis that we can do. One is called as descriptive statistics. The other one is called as inferential statistics. So, guys, if you haven't taken a note about any, if you haven't taken notes down, I highly suggest that, you guys take a pen and a paper and note down these things, because descriptive, inferential, all of these are basic concepts which you definitely require. Right. Talking about descriptive statistics. See, descriptive statistics is one of these concepts where we are trying to describe, descriptive. We are trying to use data. We are trying to, use the concepts of math. We're trying to use graphs. We're trying to use statistics to eventually expand on already data that we have, right? I'll give you an example to tell you what descriptive statistics is. Now, if there is a question that says, okay, so which sport is popular among males and which sport is popular among females, right? So your answer is going to be something like this to that question. Hey, cricket is a sport that is very popular among male players. Of course, there's female players as well. Football is another sport popular among male players. Athletics, so many things are popular among females as well. So many different things like this, right? Your question is going to make you, your answer is going to describe the requirement in the question. That is descriptive statistics. So you use mathematics and the concepts of mathematics and statistics to give and arrive at a descriptive answer which adds meaning to the problem at hand. That is descriptive statistics. The next thing is a very, very interesting form of statistics which is used everywhere around the world. It is being used right now. Let me tell you. See, with inferential statistics, we try to derive an inference based on the data that we have at hand. To give you an example, think about you guys shopping for something on Amazon, right? So whatever it is that you guys are looking for on Amazon, I think a lot of popular things right now is probably the PlayStation 5, right? As soon as if you were among the lucky few to order it or pre-order it or whatever it is, as soon as you add it to the cart and check out, it will eventually say a message saying, hey, people who bought this console also bought this accessory, this game, extra controller, or whatever it is, right? So how does Amazon know that it should recommend a controller to you, a game CD to you, or whatever it is when you're buying a console, right? As a whole, you will think of it like, hey, isn't that common sense? Someone who bought a console will also buy CDs. It is common sense, but Amazon is not a human being, right? Amazon is again a website which is run by a lot of artificial intelligence algorithms. So there it understands, it looks at your preference. If you want to buy a book, it will suggest another book of the similar genre if you guys like reading. If you're buying a pen, it will say, okay, here's a pencil, do you want a paper? All of these things come recommended manually. And guess what? Amazon is a $1 trillion worth business, right? It is huge. It is a magnet, right? So in that case, what happens is that is all the business that Amazon is making is not just from their website. It's so many things, AWS, a lot of different things. But the people at Amazon themselves say that 30% of their revenue, now 30% of $1 trillion is a lot of money. It comes from product recommendation based on inferential statistics. Now, how amazing is that? 30% of trillion is what people, as soon as you recommend it to 10 people, 3 out of 10 people will want to buy whatever is recommended there. And they're doing so. That's the average statistic. So that's an amazing number, that you guys are supposed to be looking at, right? Now, let me check out more questions from all of you all. So guys, come on, if you have any questions, you can always put them down in the comment section. I will be, more than happy to help you guys out there. So let me take a look at the questions. Madhuri says, sir, are you going to explain all about the hypothesis tests? Well, Madhuri, yes, we are going to be discussing hypothesis testing as well. Sparkart's distinction asks, do we need linked list graph array knowledge in data science? Of course, it is not a primary requirement, but down the line when you want to find out how things work, or even your knowledge about how to store data, right? If you're using other programming languages, usually everywhere you go you use arrays. Here in the world of data science, you have multiple ways you can store data. You have pandas, data frames, you have series, you have NumPy arrays, so many things. So you definitely require array knowledge on all of that. Krishna says, interview questions please. Well, Krishna, we already have job preparation section on Great Learning Academy, and of course we have multiple videos on the Great Learning channel where we have covered interview questions as well. Make sure you're checking that out. Akshit says, inferential statistics needs dataset. Of course, Akshat, to make an inference is something that you do by collecting data. So Amazon collects data from everyone who's bought a pen or a pencil and realizes they also bought a pen. So it is learning from their data to suggest it to someone else. So yes, the answer is yes, it requires a data set. Can you give one more example of descriptive statistics, right? Okay, so whenever you think about any sort of solution, if you ask a question saying, which color car is what you like, right? So probably the data set for this is all the past cars that you might have bought, or even a fantastic thing which happens in the automobile industry is everyone tries to see who sold the most cars every year, right? Which brand sold most cars. Now in the last 2-3 years we have multiple brands, new brands here in India selling cars. So in that case, if you have to ask a question saying, okay, so this person, right, BMW, Kia, or whoever they are, how many cars did they sell this month? You look at the data and you analyze it, you churn it, and you come back with an answer saying, hey, BMW sold these many cars, Kia sold these many cars, or whatever it is, right? So your answer, you're trying to use mathematics and data to give out and describe the answer, right? You're not saying, hey, BMW sold this much, so Kia sold that much. That becomes an inference. That is not descriptive, right? So I hope that example was clear. Krishna says, do I need cloud computing knowledge since I'm from stats background? Well, Krishna, it depends on where you're trying to deploy your model, right? If you are using a native cloud computing environment like Microsoft Azure or maybe even AWS or something like that, which again supports development and deployment of machine learning models and a lot of other data science concepts, yes, in that cases you would require working hands-on knowledge of cloud computing. But apart from that, you should be good without it as well. But have the foundational knowledge of it. Get a quick start, understand how things work in the cloud domain as well. Right, guys. Now, coming to talk about the statistical concepts which are very, very important. So statistics in itself, what is it in general in a quick sense, right? Statistics is how we are applying mathematics and how we use data to work with this mathematical concepts. That is statistics all in all whole, right? We use it to collect data, we use it to analyze data, we make sure we can store data in a structured way, we can organize them, we can split the data based on whatever is the requirement, right? Whatever it is, if your goal is to gain insight from data, you can use mathematics to power algorithms or to power methodologies which will eventually get you there, guys. So if you've already clicked on this video, statistics for data science, I'm sure you might already have a small idea about what statistics is, right? It's basically us trying to apply mathematics to solve a problem. That is a simple definition of what statistics is, guys. Now we have to talk about certain terms which are extremely popular in the world of statistics. The first word that you're going to hear a lot is this word called population. So see, whenever you're trying to perform statistical analysis on anything, you will have data, right? You will have multiple data points. If you bring together all of these data points, it is called as the population, the total set of observations that you want to use to get to a conclusion, right? Now if you're trying to use a diabetes data set, and if you want to understand what symptoms are having what sort of an effect on the result, right? So if you take the entire data set at once to do any operation, you're considering the population. When we say population of India, we are comparing, we're taking the entire population, every human being here in India right now. If you say the population of the world, you're considering the entire thing, right? And then there is a subset in the concept of population itself. It's called as a sample set. Now a sample set is for example, if the population of India is so and so, if I say, hey, what is the population of Karnataka, then it's a subset, right? It's a sample set. We're only taking one part of the entire population of India. That's an important thing, guys. Now as I told you, it's also called as a sample or a sample set. Sample is basically a small part of a larger population. Now, if you eat one piece of pizza from 6, you just had a sample set if you consider that as a population, right? A simple thing. If you have 1000 rows of data, if you just pick 100 from them, this is not out of the population. You have to have 1000 in total. Out of those 1000, you must pick 100 which are present in those 1000. Only then is it called as a sample, guys. So it is a small chunk of the entire population. And see, now why do we require population and sample is that whenever we perform analysis, instead of taking the entire population into account, we do it with smaller chunks called samples. This will give us an accurate solution which is eventually representable, which is eventually at the end of the day understandable, even if it applies for the population itself, right? So look at the image. Now you have multiple people standing here, out of which we just picked 5 people, and these 4 or 5 people or whatever it is, right? These exact people, they become the sample. So I hope the concept of sample, I hope the concept of population is very clear for you guys, right? Now, after you understood sample and population, the next thing that you guys are going to take a look at is something called as parameter. Now, parameter is something where we try to describe the population. We want to understand what, we want to understand more about the population itself, right? How do you describe the population? Now, if I just go back to the previous slide here, the target population is like, just if I have to say what is that, I can just say, oh, they're all human beings and we're going to pick one out of them. Next thing, if I have to say, okay, so how many of them are, banking professionals that you picked, right? So in the entire total population, I just picked a sample and those are the banking people out there. The parameter there was me finding out people working in banks. Understood that, right? It's something like that. But whenever you're working towards the population itself to maybe to find out the average salary of all of the people there, you're going to require the salary of individual people. You have the concepts of metrics of central tendency, if you guys know it, right? Measures of central tendency, mean, median and mode, standard deviation, variance. All of these concepts will bring more and more depth about the data, right? For example, if you're taking a look at the diabetic data set to find out, what is the average age of a person who gets diabetic, right? If you want to find out the lowest age, the lowest average of age where the person has diabetes, you can take all the entire data set, the entire population, or you can take a sample, and in that you can find the average age and say, okay, so here is the mean, here is the average of how of what age a person in the data set gets diabetes or something like that, right? So this is the concept of the measures of central tendency. It becomes a very very important aspect of data science itself, but it has an impact on the concept of statistics, which is used for data science. Now when you talk about mean literally means the average value of population. If I give you 5 numbers, 1 2 3 4 5, and if I say what is the average, what are you going to do? 1 plus 2 plus 3 plus 4 plus 5 divided by 5, right? So that is the average of that value. Then if I say median literally means the middle value in a sorted population. Now I gave you those 1 2 3 4 5 numbers in an ordered way, an ascending order, or I can say 5 4 3 2 1 also. If I say find the middle element for this, it is simple, right? 1 2 on the left, 4 5 on the right. What's the middle element? 3. That is the median, right? It happens like this even in real life data sets as well. But if I say 1 2 3 4, and if I say find me the middle element lies in between 2 and 3 here, right? So it is basically the average of 2 and 3. 2 plus 3 by 2. What are we getting? 5 by 2, 2.5, right? So 1 2 3 4, the median is 2.5. Simple as that, guys. And then when we're taking a look at the concept of mode basically talks about what happens when you have a data set where elements are repeating. For example, 1 1 1 2 3 4 5, 1 2 3 4 1 2 3 1, any order. If the elements are repeated again, what is the element that was repeated most amount of times, that becomes the mode of the data set, the most occurring, the most number of times an element is present, right? Now you might ask a question saying, if I just have 1 2 3 4 5 and I have no repeating elements, what is the case? What is the mode inside that? You can find mean and median. What is the mode there? The mode where all the elements are unique does not exist. That's an error, right? You do not have a mode there. You cannot say the mode is 0. Well, 0 can be repeating multiple times too, so that's an incorrect way of saying it. The correct way of saying it is, hey, the mode does not exist because no elements are repeating, right? That's an important measure of central tendency that you guys have to know. The next thing that we're going to take a look at is the measure of spread. Now, in the case of measure of spread, what we are trying to do here is we are trying to see how far away your data is spread if you put it out linearly, right? Now, if I give you 5 numbers, 1, 2, 3, 4, 5, and I give you a 6th number, 10,000. 10,000 is very far away from 1, 2, 3, 4, 5, right? It is spread out if I just have to put it down on a piece of paper, or if I'm putting it on a piece of paper, for every 1 centimeter I want to make a mark. 1 2 3 4 5, you'll do it. Now where is 10,000, right? It's going to go a long way from your paper, and then you will mark it if you're taking it on scale, right? That is exactly what if you have to find how far away things are spread out, we require measures of spread. Outlier is one of these concepts where your data either by error or by measurement or by data in its true sense itself, what happens is that is all of the data points will be similar. 1 or 2 or even a lot of data can be spread out in a way where it doesn't make sense, right? Now an outlier, a good example of an outlier is if I ask saying what is the average age of people, average age of human beings who survive right from their birth or till their last date, average age can be like what, 50 years, 60 years, 70 years, right? Now if the data is incorrect, if the ages instead of 50, 60, 70 or 500, 600, 700, the average is going to vary hugely. It's going to say the average age of all human beings is 180 years old. Well, it is meaningless now that I say it, but if you have your data to prove that it is meaningless, and it, right? You're trying to measure how far away things are spread out, and if it is either right or wrong depends on the data, but to find out that it exists, you require this concept of outlier, guys. It can be an error in the measurement, it can be true data also. You can have 1 or 2 people who might have survived for 100 years, 120 years, whatever it is. In that case also it is not considered as an error, but it sort of is an outlier because not a majority of the population get to go and be alive till 120, 130, or whatever that is, right? That is one thing. If you do not measure any of these things, what will happen is a question that you might ask. The thing is, there is a lot of things in terms of mean, median, and of course with the standard deviation is going to affect the average values. As I just told you, the average age will go from 50 or 60 to 150, 170. It will not make sense. Your mean, whenever I say average and mean, it's the same thing. So that changed a lot here, right? So that is something you're supposed to know with the measures of spread. Right now, to continue the measures of spread, there is another metric called as interquartile range. Now, what we do with data whenever it's in its normal form is we try to split the data into 4 different sections. When I say quartile, I am talking about 4. It's basically, think about all your data in the form of a percentile, right? You might have written examinations where your result is a percentile and all of that, right? So your data can be split into 4 different quartiles here. One from the most minimum point of data to Q1, that is the 25th percentile. Next you can have Q1 all the way till Q2. Q2 is again the median itself. From Q2 you can go to Q3, which is the 3rd division, and from Q3 you can get to the maximum value. So minimum, maximum, you have Q1, Q2, Q3. Simple, right? Q2 is the median. Whenever you draw a box plot, box plot is a very fancy way of how you can just show this and understand it easy. So whenever you go on to plot a box plot, you get better clarity of this, guys. So whenever I say quartile, right, it is different from interquartile range. Interquartile range is basically a measure. It is a metric, just like average, median, mean, all of that. So whenever you have a value of Q3 and you will have a value at Q1, so basically subtract Q3 minus Q1, that will give you a range. It is going to tell you how far away your data is spread. It's going to give you the lower limit. It is going to give you the upper limit, right? So for lower limit, you have a formula. Q1 minus 1.5 IQR. To find out the lower limit and the upper limit which exists in your data, you require interquartile range. To know interquartile range, you need to know all of these data. What is your minimum value? What is Q1? What is Q2? What is Q3? What is max? Right? So to find lower limit and upper limit, you require IQR. To find IQR, you require the data to be in its quartile form. That is how measures of spread works, guys. So that's an important thing that you guys have to know about. Now, talking about the next important metric, I have an amazing story to tell you guys here with measures of accuracy, right? So see, there are 4 measures of accuracy: true positive, false positive, true negative, and false negative. Now guys, if you have ever heard of these terms, usually you might have heard of false positive a lot. True negative and false negative might not be something you might have heard. True positive is something you might have heard. So if you know what these are, quickly head to the chat box and let me know what you think they are, right? Alright, now let me tell you a story to teach you about what measures of accuracy mean. Now in this case, let us go back to the time when dinosaurs walked the earth, right? They were majestic creatures. I absolutely love everything about dinosaurs. There is a situation here. Now there is a farmer and a village at the edge of the forest where dinosaurs live in that forest, okay? So this is the situation. A farmer is farming in his farm where his village is a little far away, but there is always a risk of dinosaurs coming and eating people and all of that thing. So we do not want the farmer or the village to be destroyed by dinosaurs. This is the story, right? Let me give you 4 situations here. The first situation is there is an actual dinosaur. There is an actual dinosaur. The farmer who's farming sees the dinosaur. Maybe it is a Tyrannosaurus Rex, T-Rex as it's called. It is a carnivore. It eats human beings, right? As we have seen in the movies. Now, so there is a dinosaur. The farmer saw the dinosaur. What does he do? If the farmer is correct, he runs back to his village. He says, there's a dinosaur coming. Run. So everyone runs. This is one situation. The second situation is, there is no dinosaur. The dinosaur is somewhere inside the forest. The farmer thinks he saw a dinosaur. Maybe he saw a bush, a plant moving or something. He's scared. He saw a dinosaur is what he thinks. He runs back to the village and says, hey, there's a dinosaur coming, let's run. So everyone runs away, but no point. There was no dinosaur at all. So the farmer is incorrect, right? This is the second situation. The third situation, there is an actual dinosaur. Farmer was maybe busy showing his back to the forest. He didn't realize the dinosaur sneaked up on him, and eventually he had to run. It killed the farmer. The village is destroyed because dinosaur came and destroyed everything, right? So in this situation, there was a dinosaur. Farmer said there was no dinosaur, right? So what happens? Dinosaur destroys the village. Simple. The fourth thing, there was no dinosaur at all. It's probably very far away in the forest, or it is not anywhere near to the farmer or the village. The farmer says, well, there was no dinosaur. I didn't see any dinosaur at all, right? Farmer is correct. There was no dinosaur. He didn't see any dinosaur. So what? All's good, correct? Simple. That these are four situations that I'm going to use to explain four individual cases of measures of metrics. The measures of accuracy, guys. Instead of dinosaurs, let me give you the current situation. Current situation is with COVID-19, right? The pandemic. I am sure everyone, whoever is watching this video, knows that we are living amongst a pandemic. Most of us, probably it's our first time in our life ever that we are living among a worldwide pandemic, right? Think about the first situation, the top left box. This is a situation that now I'm going to tell you about in terms of COVID-19. Now, the situation is that, there has to be a test conducted to know if a person is COVID-19 positive or he is negative, correct? So, in this case, dinosaur is COVID-19. So, the person who is gone to get tested has COVID-19. The people who are testing, they test him, the result comes out to be positive. They say, hey, yes, you have COVID-19. Please isolate yourself, quarantine yourself, or whatever that is, right? That is one case. The person has COVID-19. As soon as he went to get tested, the test came out to be positive. So he has COVID-19 for sure, right? One case. Take a look at the top right case. There was no COVID-19 at all. The person just is maybe having a little bit of fever, cold, cough, regular symptoms which is not from the virus. He goes to get tested and somehow the test came to be positive, right? Are you understanding what I'm telling right now? He doesn't have COVID-19, but the test came out to be positive. There was an error in the test. This is called as a false positive, right? It is not the actual truth. It is away from the truth. The person did not have the virus. The test said the person has the virus. So what will the poor guy do? He's going to go back home, quarantine himself or something like that, or he's going to just get very worried or something. Now take a look at the bottom left situation. The person has COVID-19. He or she may be asymptomatic, not showing any symptoms. He goes to get tested. For some reason, the test comes negative now. Whose fault is it? Well, it is an error probably in measurement in the test or whatever it is, right? The person actually has the virus. The test says, no, sorry, you don't have virus. You're negative. Happily enjoy. So that person is going to go and sort of spread the virus to a lot of people, which is not what is wanted right now in the world, right? That is the bottom left one. Take a look at the bottom right situation. The person does not have COVID-19. He just goes to get tested randomly to say, hey, I want to get tested. The test comes out to be negative. They say, you're fine. You don't have COVID. So he comes home happy, right? So these are the four situations. Now, you remember we spoke about, these four metrics, true positive, false positive, true negative, and false negative. Well, these are the four situations I told you with two stories right here. The first on the top left, that was true positive. On the top right, we have false positive. On the bottom left, we have false negative. On the bottom right, we have true negative, guys. So make sure you take a note of all of these. If you get confused about, this is basically a matrix form, which you definitely will have to remember. I'm going to show it to you practically. But if you have to remember it, whenever you're drawing an X like this, right? So it's true positive, true negative, false positive, false negative, X. Right? So just know the order: true positive, false positive, true negative, false positive, false negative. Right. So I hope you guys were clear with that concept. So using those four values, we find out the actual metrics of accuracy, which is sensitivity, specificity, precision, predictive, negative, and all of that. So each of these has a formula on its own. For example, sensitivity, you find out by taking the value of true positive, dividing it by true positive plus false negative. Then you have specificity. It's true negative divided by true negative plus false positive. You have precision. This is a metric to analyze the values, it is true positive divided by true positive plus false positive, and predictive negative, which is true negative by true negative plus false negative. Now guys, each of these metrics, sensitivity, specificity, precision, F1 score, all of these things have a specific meaning. Using these metrics, you can say how accurate is your data. You can try to see, for example, what do we want in real life? We want to make sure all the cases where a person gets tested and is positive, probably to be correct. We want the test to be correct, so we want to track all of that. Now what do we want to make sure that we keep it to the minimum? All these false positive cases, right? Or the worst case in my opinion is the false negative case. The person has COVID, but the test comes out to be negative. We do not want that, right? We do not want a positive person with the negative report spreading it to everyone. That is an important thing. So to check out what is the measure of accuracy in terms of bringing down the false negative cases, you require either of these metrics. So each of these metric has a meaning on its own, guys. The next thing after measures of accuracy that we're going to take a look at is hypothesis testing. Let me quickly give you a conceptual meaning of what hypothesis testing is. First of all, what is hypothesis? Hypothesis is one of these tests that we do, before even making a test, we guess something. We think that the solution might be like that, right? For example, a hypothesis can be a very simple thing. I'm going to give you a real life example, a beautiful example of hypothesis testing. Think about the planet Pluto, right? I remember when we were in school, we were told that there were so and so planets in the solar system, and the last planet, Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Pluto. Pluto was also a part of the solar system, right? That the initial hypothesis will be something like this. Pluto, I assume that Pluto is a planet. Correct? That's my hypothesis. I'm guessing. I want to guess. Now I think about, I don't have data. So I'm guessing that Pluto is actually a planet, right? So that's my null hypothesis. So the concept of null and alternate hypothesis, I'm going to explain with the use of an example. With null hypothesis is basically an accepted fact. It is used to accept the assumption. Now my assumption that Pluto is a planet, right now it is correct. There will be an alternative hypothesis which will state, no, sorry, Pluto is not a planet. Right now, if you're a person who loves space stuff like me, looking from the past till now, there has been situations where people say Pluto is a planet, then they say no, sorry, it's not big enough to be a planet, or something like that, right? So our original hypothesis will be proved false if the alternative hypothesis becomes true. What is the alternative hypothesis in our case? It is that Pluto is no longer a planet, right? So if Pluto is not a planet, your original hypothesis of you saying, hey, I don't know, whatever it is, Pluto is a planet, is wrong. Correct? So this the way of you assuming things and then having a contradiction to it and using these two to analyze what is right, what is wrong. Well, to do that, we use hypothesis testing, guys. Now, hypothesis testing, I gave it to you in a conceptual value. To think about the mathematical side of things, you have something called as the p-value. Now, p-value is like a numerical measure where we either try to reject the null hypothesis, or we say that the assumption is wrong. We either try to support it or reject it, right? Let me give you an example. Let's say if p is less than 0.5. If p is less than 0.5, null hypothesis is accepted. It means that if p is less than 0.5, I agree that Pluto is not a planet, because my alternative hypothesis, if p is less than 0.5, I will say that Pluto is a planet. If p is greater than 0.5, I say no, sorry, the null hypothesis is no longer correct. It is rejected. So we will look at alternate hypothesis, and alternate hypothesis says Pluto is not a planet, right? I hope all of you guys were clear with all of these concepts. Shivendra Sharma, obviously, TP correctly predicted predictive positive classes, TN correctly predicted negative class, FP incorrectly predicted a positive class. Perfect. Thank you so much, Shivendra. I hope all the people in the comment section absolutely use your insight on this as well, guys. So this is p-value. Now, I want to show some of these concepts to you guys practically as well. So let us take a look at a data set where we try to understand diabetes. We try to predict if a person has diabetes or not by performing a lot of statistical analysis on it, and of course using a little bit of help from machine learning as well. So guys, let me go on to Google Colab. Google Colab is basically a Python Jupyter notebook hosted on the Google Cloud platform. It is free to use, it is open source. I absolutely love using it because I do not have to install Python on my machine. Whenever I'm in my car, whenever I'm flying anywhere, I can just go on to write Python code. I can run it. There is no error, there is no dependency, there is no environmental variable, all the things that I have to worry about, right? So that's why I go on to use this, guys. So we're taking a look at the diabetes data set here. So let me zoom in so all of you guys can see very well on your screen. Let me zoom out a little. Perfect. So guys, whenever we talk about any practical example, what is the first step? The first step is to import all of our libraries, right? Now in this case, I am importing NumPy, Pandas. NumPy is used to create arrays for numerical computation. We have Pandas. Pandas gives us data structure storage ways. It gives us data frames. It gives us series. We can go on to perform statistical computation. We can make sure that we are making use of numerical computation and statistical analysis as well. Then you have Matplotlib and Seaborn. Matplotlib and Seaborn are popular for what? Data visualization, right? So we make use of Matplotlib and Seaborn for all of that. And then you have scikit-learn. Scikit-learn is very, very popular in the case of statistical analysis and machine learning, guys. So let me import all of these packages. Perfect. The next thing is I want to bring in the actual data set that I'm going to use. But if I run it now, it's going to give me an error. It's going to say, hey, where is the data set? I do not understand it, right? So let me upload the data set by clicking on the files tab on the left side one. I have the diabetes data set here. You can see here there's a yellow circle. It's uploading. You see now it says diabetes.csv is uploaded. Now let me run this again. It should run fine. Now what we're trying to do is we're trying to use a function in pandas called read_csv to bring in our data set itself to our working environment. After that, let's take a sneak peek into the data set. Let us understand what we are looking at. What data is it that we're taking a look at, right? To explain the data, I already told you guys that we're going to be trying to see if we can predict a person has diabetes or not, and what are all the variables to see if a person gets diabetes or if he actually has diabetes, right? You can check out so many different data that's given here. The first thing is, you can check out the number of times the person was pregnant. Then you have the blood glucose level. You have the blood pressure level. What is the BP? What is the skin thickness? What is the value of insulin? What is BMI, body mass index, right? So BMI is usually 25 is something that is supposed to be required. 33 means that the person is very obese. Anything less than 25 means the person needs more muscle and weight and all of that. Then you have something called as age, right? Age is a very important factor to find out if the person has diabetes or not. And outcome is a place where we are trying to say if the outcome is 1, it means this person is diabetic. If the outcome is 0, it means this person does not have diabetes, right? So these are sample 5 rows that I just printed out for you guys, and these are all the columns in discussion. Pregnancies, their blood glucose level, their BP, which is blood pressure, their skin thickness, insulin, BMI, the pedigree function, the age, the outcome. So we are taking a look at a lot of different variables to perform multivariate analysis to see what which of these features have an impact on the outcome, right? So to print a little bit about the details of the data set, we have 768 patient data. Now this can be a hypothetical data set, but in the data that we have, we try to predict if a person has diabetes or not, right? So we have 768 people worth of data that we're going to use. Now to take a look at the statistical aspect of the data set. Now this is where I told you all the important statistical concepts come into the picture, right? Now take a look at the values. Count is basically giving us how many rows of data that we have. Of course, I just told you it is 768. The mean of all of these is basically the average, right? So the average blood pressure of all 768 people is 69. The average insulin level out of all 768 people is 79. Average of body mass index is 32. So you can see if you take the entire average of all the people, it is showing that this population might be slightly obese, right? Then you have the standard deviation, and here is where the interquartile range comes into the picture, ladies and gentlemen. Take a look at this. You have the minimum value, the 25th percentile value, the 50th percentile, see this Q1, Q2, Q3, and minimum to 25 is Q1, 25 to 50 is Q2. This is also considered as the median. Median is the middle element, right? Next you have the 75 percentile, which is the Q3, and you have max value. So with max value, all I am trying to say is the maximum blood glucose that a person had in the entire data set is 199. The maximum insulin that a person had, the blood sugar level or whatever it is, was 846, right? So it's something like that. This, I just wanted to print this out to you guys to tell you that if you use dot describe a function, it is going to give you so much. Now I didn't have to look at 768 rows to find out what is the minimum value of insulin in someone's body, what is the maximum value, what is the average body mass index, what is the standard deviation for the blood pressure from the average, and all of these things, right? So the next thing, as I told you, you have to pre-process data. Let us check if we have any data here which requires pre-processing. Now all the data here is numerical, right? There is no character data. I have not asked blood group here. If I had asked blood group, it would be O positive, O negative, A, B positive, all of those things. So when it says false, it's trying to tell me that, hey, everything here is a number. NaN means not a number. Of course it is false because everything here is a number, correct? That's one important thing here. So nothing to pre-process here. This data is already pre-processed. Next, to understand correlation that exists between the label. Now this is a very, very beautiful graph to look at. I always love looking at correlation. Let me zoom out a little, because or else you won't be able to see, or in fact I can zoom in to show you one or two correlations, right? Now guys, on the right you have a legend here which goes from a very dark color to a very light color, correct? The dark color says two labels have nothing to do with each other. If it is light, it means, hey, all of these labels are related to each other. I'll give you an example here. Now, what is the second column here? Second column is the glucose level, right? So the vertical column. Now, if I take a look at to see if skin thickness has anything to do with glucose level, it is dark. It means that there is some relation between these two. Now wherever it is black, it means there's absolutely no relation or very minimal. Now what is the let's take a look at pregnancies and skin thickness, right? So it is saying that, hey, in the outcome of a person being diabetic or not, pregnancies and skin thickness and insulin rate does not matter. Now this is not a medical opinion, this is as per our data set, right? Now if you find a light color here, age. Now age has something to do, age has a good amount of correlation. It is related to the number of pregnancies. Age has a correlation, a minimum correlation with body mass index, right? So we are going from 0 to 1. Sometimes instead of 0 there can be a negative correlation. For example, how does age vary? I'm giving you a positive correlation example. How does age vary with diabetes? There's a good chance when they become 40, 50, 60, diabetes sets in. For a person 2, 3, 5, 10 years of age might not get, right? So diabetes is directly proportional to the age is something that I can say. If it is something reverse, right, so then maybe I can say, if a person is losing weight continuously, the person is becoming more and more fit, then what happens? The chances of the person losing weight will make sure the person's capability or the ability to onset diabetes is also going low. So the person's weight is inversely proportional in a metric to that concept, right? That is what I was trying to tell with that. Now if I have to print for you guys total number of people in our dataset who do not have diabetes, it's 500 people. How many people have diabetes? It is 268 people, right? It's all a simple for loop, and I'm using an if else loop to print all of these for you guys. So it's a simple thing. I'm trying to find out the outcome. I'm trying to see how many in this outcome is 0. So if all of these people, if I just pick up the number of times I find a 0 in the outcome column, it means all of these people don't have diabetes. I'm printing it. Now if that becomes 1, it means, hey, these are the number of people. If the result of I is 1, it means for every time you search, if you find a 1, add 1 to your number. So there, I'm trying to say 500 people do not have diabetes, but 268 people have diabetes, right? So let me quickly print it out in a count plot to show it to you beautifully, right? Look at this. No diabetes versus diabetes. So people with the count 0 means there are 500 people without diabetes and 268 people on the right side who do not who have diabetes. On the left, it's who do not have diabetes. So majority of the people do not have diabetes in our data set, but 268 people do have diabetes, right? So now what we're going to do is we're going to use a little bit of quick machine learning to give us even more statistical insight. I'm going to split the data into testing and training. Testing is used to verify if the machine learned something, but for the machine to actually learn, we're going to use the training data, right? We're going to be using the concept of logistic regression to train the machine and perform some prediction on the same. Now here is where the last step of basically guys, the 3 lines of code that I just executed, L equal to logistic regression, we're trying to fit the training data and we're using the testing data to verify if the model learned anything. That was machine learning. 3 lines of code, right? Now look at the confusion matrix, guys. This is what you as a person looking for statistics and data science should be looking for. The 4 values that you see there are talking about the measures of accuracy, guys. True positive, true negative, false positive, false negative. You remember those 4 situations I spoke about? These are the number of cases for that. Now I told you, that we want certain values to be high, certain values not to be high. For example, true positive, yes, we want that to be high. We want the correct number of ratings, right? True negative, yeah, okay. So true negative also you can take a look at it. The person did not have diabetes. The outcome, the result, the test showed you don't have diabetes. Perfect. So these 2 values, whenever you're looking at a confusion matrix, needs to be high. These 2 should be low because these are the opposite cases. The person had COVID-19, the test came out to be negative, very dangerous. Then the person did not have COVID-19, the test said, hey, you have COVID. So the person is now scared. The person is simply isolating himself for no reason, right? So to understand what we can predict from our machine learning algorithm is this. This is how the machine learning algorithm predicted using the concept of statistics. So for all the questions that I was getting, saying, how can we use statistics for machine learning to drive the output? This is exactly what you see on your screen right now, guys. And next I can print the final accuracy score. When we use a logistic regression model, we have 75% of accuracy in our machine learning model, detecting detecting the accuracy of a person, if it can predict if a person has diabetes or not. And at the end of it, look at this. These are the metrics that we took a look at as well, right? Precision, recall, sensitivity, specificity, all of these things. So precision again talks about how correct is your data whenever you're taking a look at the cases where people did not have diabetes. That is what 0 means. Next one, for all the positive cases where all the people had diabetes, how accurately did you predict that? Then again, recall, specificity, sensitivity. Again, all of these comes together, at the end of it to give you a beautiful looking chart. Now you have to be well versed in statistics to read an entire graph like this. Each of these concepts are a measure of accuracy, guys. F1 score is again where you have to take recall, precision, multiply it, multiply 2 into it, add, divide. So again, it's a very complex formula, but it is a formula that exists that you guys should know about, right? So this is a quick start for you guys who are looking at statistics for data science, guys. So with this, we come to a section where I guide you all about how you can learn something further. Now here at Great Learning, we have multiple places where you can learn more about data science, more about statistics and all of that, right? The first place for you guys to check out is definitely Great Learning Academy, where we have multiple courses for free. You can learn for free, enroll for free, and at the end of the day get a certificate of completion absolutely free as well. Make sure you guys are checking out Great Learning Academy. After that, I highly suggest that you guys should take a look at the Great Learning YouTube channel, because we have multiple subject matter experts putting out videos for you guys, so you guys can learn for free as well. So make sure you're checking out the Great Learning YouTube channel, and we have Great Learning blogs for everyone who wants to who loves to read, and maybe you want to read and learn. Well, you can do that here as well for free, right? So now all of these free things will definitely get you a good head start in the industry. But if you're a person who's looking to become a complete professional, an expert in data science, I highly suggest you take a look at the offerings we have in terms of specializations and post graduations here, guys. So we have multiple post graduation programs, MTech programs and MS programs that are done in collaboration with some of the most prestigious universities across the world. We are tied up with Stanford, Texas, Northwestern, PES, multiple different universities across the globe, and of course Stanford is an Ivy League school as well. So With this, you will be learning from the professors of these universities along with other subject matter experts, industry professionals. You will get one is to one, one-to-one mentorship. You will be helped in terms of job assistance. Basically, to wrap it up, you will go from a complete beginner, and you will go. These courses are usually somewhere around 6 months in duration. Write these programs. At the end of it, you guys will become a thorough expert in the domain itself. So you will have complete working knowledge. You will be industry ready. You will be working on multiple projects which are all industry level. All of them are practical things that you will, which is eventually going to help you land a job and work on similar things as well. So keeping all of this in mind, we have curated multiple programs here that's going to take you guys, it's going to guide you, it's going to handhold you from being an expert, from being a beginner to going to becoming an expert, guys. So make sure you guys are checking out the specialization and post-graduation offerings we have here at Great Learning. So on that note, guys, you've come to the end of the session. All of you who ever tuned in, thank you so much for tuning in. I hope I was able to give you an ample amount of knowledge, a quick start about statistics for data science. I hope all of you guys got to take away a lot of information from here. If you liked whatever you saw on your screen, ladies and gentlemen, take 1 second to hit that like button for us. It will mean a lot to us. And subscribe to the Great Learning YouTube channel so we can bring in more free content like this for you all, right? So make sure you're liking the video, make sure you're subscribing to the channel, and of course check out Great Learning Academy for all these free courses, and to earn a free certificate of completion, a course completion, the certificate of completion for your courses, right? You can get that for free as well on Great Learning Academy. So make sure you check it out, guys. Make sure you stay safe from the ongoing pandemic. Wear a mask always, sanitize often, do whatever it is to make sure that you guys are staying safe, and at the same time stay safe and keep your learning up. Make sure you're learning. Now is the time that the entire world is ramping back up on jobs. Everyone is hiring rapidly now. The world is changing in terms of trends. Everyone wants to hire an expert these days. So make sure you're working towards that. Make sure you're learning. Make sure you guys are using all of the tools that we are providing here in all the videos, all the content. Make sure you're using it fully to learn, guys. So I wish you all the very best. I hope you have a nice day ahead, and I'll see you on the next one, guys. Cheers. Thank you so much for tuning in. Have a nice day ahead.